Okay, so last time we left off with acid anhydride reactions. Okay, so remember, last time we looked at anhydrides reacting with water. Okay, so let's pick up with that. And now, let's look at anhydrides reacting with an alcohol. Okay, so here the nucleophile is an alcohol. Okay, so remember these anhydrides. Okay, where we have this kind of thing. Okay. Remember that the leaving group is one side of this. Okay. So last time we had water, this time we have the alcohol coming in and kicking off that big leaving group. Okay. So if we get that to happen, we get these things forming. Okay. So the alcohol is added on. My carboxylate has left. And then lastly, this oxygen can take an acidic hydrogen. Okay. So we end up getting these two products here, okay, where, again, remember this one here is an ester, and this one carboxylic acid, okay. So just like in acid chlorides, the byproduct was always HCl, here in acid anhydrides, the byproduct is always a carboxylic acid, okay. So make sure you have it down. Anhydride plus alcohol gives you ester and carboxylic acid. Okay. Any questions on that one? Okay, let's go to the next anhydride reaction. Okay, so the third one will be where the nucleophile is an amine. An amine. Okay. So let's redraw our anhydride. This time, let's react with an amine. Okay, so we get the same setup as we've seen. Okay, again, get in the habit that this big thing here is your leaving group. So the nitrogen attacks and kicks that big leaving group off. Okay, so the amine has added on. We have this leaving group here. And what will this go after again? One of these acidic hydrogens. Okay. So if you look again, you're getting the carboxylic acid as a byproduct. And the main thing we're forming is the amide. So any questions on anhydrides reacting with amines? Okay, so these are very similar reactions as we did with the acid chloride, okay? Just that you have a different leaving group here instead of Cl. Okay, so those are the anhydride reactions, okay? Let's go to the next set, which are the esters. Look at ester reactions, okay? And there's two main ester reactions that we want to be familiar with. Okay, the first one is transesterification. Okay? Anybody figure out maybe what that word means? Okay, so maybe you're thinking of a trans double bond. Okay. Anybody else? Okay. Yeah, we're going to esterification, so we're going to make what? An ester. Trans, okay, means across, okay. What this means here is that we are going to start with one ester and make another ester from it, okay? So we're going to change esters from the original ester, okay, if you follow that. So let's look at an example to see what this means, okay? Let's suppose we had this ester here. Okay. And what we do is we react an ester with an alcohol, okay? And this alcohol is going to replace this alcohol, so we get a new ester. This thing here. Okay, so that's what a transesterification does. We start with one ester and we produce another ester. Okay? So this is one of the ones in this chapter 2 we need to study the mechanism of, okay? So let's go ahead and look at that. first step, notice we have an acid catalyst. The reason for that is that this thing here is not a very good leaving group, so I need to activate the molecule a little bit, okay? So I'm going to protonate the carbonyl to make that carbonyl more reactive. Okay. If you recall, we didn't need to add a proton to carboxylic acid chlorides or anhydrides because they had very good leaving groups and their carbonyls were very reactive. But now I'm coming down the hill, and so this isn't as reactive, so I need some help. So now, if I protonate, now I can have my alcohol attack. Okay. So there the phenol has added on, which then creates that acidic hydrogen that we can remove. So now the phenol is fully added on. So now I got 3 oxygens there. And I'm kind of like at my halfway point, like the hemiacetal or hemiketal. Now, which of those 3 oxygens do you think will get the H+? You got this one, or that one? Okay. Well, in the past, we've done what? Added it to the alcohol to make water, which was a good leaving group. Okay. Well, here we're not going to use that one. Whoever blurted out OCH3 was right. Who blurted that out? Nobody wants to take credit for it? Okay. Well, all right, if you don't want to own your answer. It's going to give you an A for the course, but... No, everybody owns it. Why don't you raise your hand, Quimby? Because it was a female voice, wasn't it? Okay, so we'll choose that one to add on. And that creates the alcohol here, which is a good leaving group. Okay, so that alcohol then leaves.
Okay.
So we get the carbocation. Remember in the past, once we got to this step, we could draw what? Resonance. So that's what we will do here. So we're almost there. Okay. So you can see how this looks very similar to our product. We just have to remove that acidic hydrogen. So let's do that. Okay, that gives us our phenyl acetate. Okay. Okay, so fairly involved mechanism, but it's really nothing new, is it? We've been doing these things over and over from our aldehydes and ketones. Okay? So this is the transesterification. The only thing that's new again is that this oxygen gets protonated to give us our leaving room instead of forming water there. Okay? Any questions on that one there? It's almost like we're doing the same thing over and over. Okay, so this is transesterification, one ester to a new ester. Okay, let's look at the second kind of ester reactions. Yeah. Okay, the second type of ester reactions are the saponification reactions. We've already looked at saponification in the past, remember that? What did we form? What did saponification form? What does it sound like? Soap. Okay. I'm trying to wash my hands. Okay, so this saponification means soap making, okay? So we've seen it before with carboxylic acids. Let's look at it with esters. Okay, so here we react our ester with a base. And the base that we use is usually sodium hydroxide or potassium hydroxide, KOH. Okay, so let's see how this reaction occurs. Again, whenever you see sodium hydroxide or potassium hydroxide, just immediately draw OH minus. Okay? Where's that OH minus going to attack? The carbonyl, as before. So it comes in, and it's going to kick that OCH3 off. and we get this carboxylic acid and OCH3 minus. But this thing here is a good base, and I got what? This acidic hydrogen. So we get one last reaction. So what we end up forming is a carboxylic acid salt and the alcohol. Okay. So write it down. A saponification reaction transforms an ester into a carboxylic acid salt. Okay. Remember, these carboxylic acid salts were water soluble. The reason that it's saponification is that if we did this reaction on a fat molecule, you might say, what's a fat molecule? Okay, a fat molecule is a triester molecule that has these long carbon tails. Okay? So this is the setup for a fat. Okay? So a fat is something like butter or lard or something like that. Okay? It has these long carbon tails. This is the way they used to make soap. They would take fat or lard and react it with base. Okay. And then what would happen there? Put the phone down. Well, the result of this is you would get 3 of these things forming here, where you have a fatty tail and this polar tail. Okay, remember what they combined to make? What was that thing called? Start with an M. The micelle. Okay, so these things, a bunch of these things aggregate together. And you end up forming this micelle. Okay, where you have these polar tails sticking out and the non-polar inside that could grab the dirt, and these outside could mix with the water. Okay. And this was how you form soap. So this is how they made soap. Okay? We have different ways of making soap today. Okay? So you get some better soap than what they did in the 1800s. Okay? You like your soap? But what we used to do is have a lab where we did make soap, which was kind of fun. You know, students go over to the cafeteria and get a stick of butter, chop it up, put it in the flask, add some sodium hydroxide, reflux it, okay? And afterwards you would let it cool down and rub your hands and it starts sudding up. You had some soap. Okay, didn't smell very good, but it still soap. Still did the job. you're ever stranded out there. Know how to make some soap. Okay. I heard of somebody washing their child's teeth, their child's mouth out with soap. Ever have your mouth washed out with soap? You know how they wash their mouth out with soap? They took a toothbrush and wiped it across the soap. Then they brushed their teeth with the soap. Anybody ever had that done to them? You did. How'd that feel? Didn't taste very good. I won't ask why you had your mouth washed out. All right, so that takes us down to the last molecule in the chain. And those were the amides. So let's look at amide reactions. Okay. And for amide reactions, these amides are not very reactive. And so they basically only undergo what's called hydrolysis. Okay? And there's two kinds of hydrolysis reactions for amides. Okay? Two kinds of hydrolysis in general, either a base hydrolysis or an acid hydrolysis. Okay? So let's look at a base hydrolysis. Okay? If you look at your outline sheet, the base hydrolysis, your product is going to be a carboxylic acid salt. Okay? So let's take a look at an example. Okay, so here is an amide, and let's use a base like sodium hydroxide. Okay. So again, remember when you see the base, it acts like OH minus. So it's going to come in and substitute for the NH2. Give you the carboxylic acid and the amide ion. Okay, remember sodium amide. What do you think is going to happen at this point? It's almost done.
Take off the hydrogen.
Right, it's going to be like the saponification reaction. Remember that? So here, acidic hydrogen, and here, very strong base. So it's going to take off that acidic hydrogen. And give you the sodium salt and NH3, ammonia. So any questions on this hydrolysis reaction? Okay. Remember, sodium hydroxide is mixed in with water. Okay. That's what hydrolysis is you're reacting the molecule with water. But here I'm reacting with water and base. So we call that base hydrolysis. Okay. All right, let's look at the other hydrolysis reaction, which will be the acid hydrolysis. And if you look on your outline sheet, the acid hydrolysis gives you the carboxylic acid as the product. Okay. So let's take a look at an example. So in acid hydrolysis, we'll take an amide and react it with water and acid, okay? So that's what this H3O plus, it's a H plus on water to give you the hydronium ion. Okay, and here we end up with the carboxylic acid and ammonia. Okay, won't hold you accountable for this mechanism. Just know the product. Okay. So let's stop here and let me give you some practice problems and see if you can work them out. Some of these reactions I'll put up will be from today, and some will be from the past, okay? See if you can work them out, and I will call on you to see what your answers are. Okay, see if we can work on those. And I'll call people to the board to work those out.
Yep. Yes. I know this is out. Me too. Today,
Okay, so everyone come up and do the first one. First one's easy. George, you're coming up second. So you better be ready. Now, wait till she's done. You don't have to draw the mechanism, just draw the product. Okay, good. What kind of molecule is that? All right, very good. Very good. Okay. Anybody have a problem or any questions with that? George Tan, please come forward. Okay. Anybody have a question with that one? Anybody think that's right, wrong, or? Okay. What kind of reaction was this? Saponification. To give us the carboxylic acid salt. Okay. Any questions on that? Good job, Joel. Who wants to come up for the last one? Am I going to choose somebody? Okay. Guess I'm going to have to choose somebody. Puckett.
What are you calling me for?
Yeah, why don't you come on up? I don't think she wants to come.
You have to give me some time. I can talk to somebody.
Maybe 5 minutes.
cover your.
Okay, good job. So again, you get the carboxylic acid salt. This is the base hydrolysis of the amide that we just did about 5 minutes ago.
I got a question.
Yeah.
Can you tell me the reason why she left off on the first problem, the rest of it? The CH2, the 2CH2 and CH3?
Oh,
Sorry.
oh yeah, yeah, you forgot this? Get back up here.
My apologies.
Okay. I didn't call you out, she did.
I'm sorry.
Okay, so you can talk to her later. All right, any other questions about these? Okay, so these are just warm-up things just to keep your minds in the game. Okay. All right, so if you didn't pick up your homework, you can get it now.